Cooperate. Cooperate. Okay. So which one? Sorry.
51 on chapter 1.
Chapter 1?
Number 51.
151?
No, 5.
51, okay. Sure. Oh, all right. What's a more concise way to write that? Don't actually do it, just write it in a different way. Don't say 49. What's a more concise way to write that?
7 squared.
7 squared. What's a more concise way to write that? B squared. So what's a more concise way to write that? X plus 1 squared. Good. If I have something times itself, it's that thing squared. I don't care how big. I can have x cubed minus 4x squared plus 7 times x cubed minus 4x squared plus 7. That is x squared minus 4x cubed plus 7 squared. That's a more concise way to write it, because that exponent tells me that there are 2 of these multiplying. That's what the exponent means. So it's a more concise way. Because I'd much rather write this than write 80 freaking x plus 1s, right? So thankfully, we developed this shorthand. Cool. I like it. So don't actually FOIL it out. We officially don't even know how to FOIL it yet, but we should all kind of know how to FOIL. Don't FOIL it, just rewrite it with an exponent for that problem. Oh, this was 51, chapter 1. Any other questions from homework? Yes?
Chapter
2, 1? In which problem? 57? Oh, good. All right. Oh, yeah, good. All right. So here's a really good place where I'm going to put numbers into the thing I don't know. Let me say this again. So for this specific example, it tells me a football field is 300 feet long, right? So one football field is 300 feet long. And it says, write an equation that gives the length L in feet of X football fields. And you're like, oh shit, there's freaking variables all over the damn place. So I want to know if I had X football fields lined up, and I had X of these things, what would the actual length, total length be? So I'm going to give myself a specific situation and try to see what my brain does. If I had 2 football fields, how long is it? Total? 600. If I had 3 football fields, how long is it?
900.
Yeah, so 2 football fields is 300 times 2. 3 football fields is 300 times 3. Let me stop there for a second. You guys see what I'm doing? You're completely allowed to do this, because what is X? Whatever the hell I want it to be? Shit. Maybe not -1, because I don't know how I can have -1 football fields, but you can make it whatever you want. Oh, sure. I don't know why. Hopefully it's not. Okay. All right, how are we doing so far? So in each case, what does the 600 represent? What's that 600 represent? The total length. And this 2 was the number of football fields. So in here, this will be X. It's not 2 or 3. I just put that there to see what my brain would do. Our brains will latch on to numbers. Our brains don't latch on to letters. It's not entirely your fault. Our brains are not hardwired to latch on to letters. We have to go, okay, brain, got to train you. So this is what I do. You put numbers in and you go, oh, my brain just multiplied 300 times the number of football fields, and X is the number of football fields, gives me what?
Length.
The total length. Bam. There's the equation. So if somebody came along and said, yeah, I got 3 football fields in a row. Now you've got an equation, oh, 300 times 3 football fields is 900 feet total in a row. That's what you got. Or if somebody said, I want to build 4 football fields end to end, so I can have all these practices. They're like, how long, how much space do I need? You with me? Put a 4 in, 4 times 300, you need 1,200 feet. Maybe a little more just as a buffer zone, right? You guys understand what I'm saying? A little bit? Here. All right. So you are completely allowed to plug numbers in, make them nice round numbers or small numbers, and just see what your brain does. Give yourself a specific situation. You can't, it's very difficult to just jump right into the formula. You got to do a few examples and go, oh, this is the formula. 300 times however many football, oh, it's X, because I don't know, gives me the length, L. Bam. And that's part A. So now part B should be relatively easy. What's part B say? Use a formula to write an equation whose solution gives the number of football fields in 870 feet. So in this equation for part B, where would this number go? You wouldn't go for X. If I put it in for X, that means I'm saying I have 870 football fields. Okay. That's basically, if you have a small country, your whole country is football fields, basically. Oh, shit. Right? That's a little many. So that's the length. I'm going to put it there. And then it can solve that equation for X. And that's part C.
What question is that again?
This is number 57. In section 2.1. Yes, sir.
In section 2.2, 78.
Is there anything else about that problem there? I mean, I didn't finish it all the way out.
So you would just be
Say again?
you would just be 870 feet.
No. B says use this equation. If you do have a total of 870 feet, how many football fields would you be able to fit in there? Is really what they're asking. That's a better way to organize those words. So where does 870 go? Yeah, and then you can solve the equation. Now you'll get some weird decimal number, so you don't want to give, yeah, kids, sorry, we got 0.9 of a football field for you. All right, just don't run too far at the end. You're going to smack into the concrete wall, sorry. All right, so that's kind of sucks. But you'll get a decimal that represents how many football fields. There'll be so many, and then a piece of a football field. So maybe you don't want to build that last one. All right. Okay, maybe. All right.
It's number 78 in section 2.2.
2278. Oh, okay. So this is a lot like part B on this problem. So the non-true word problems, the problems that already give you an equation. All you got to figure out is if they give me a number, where do I put the number? If I put it in the wrong place, I'm going to get something that makes no sense. So in this problem, they give you the equation. This is sorry, I've forgotten everything about it. 78. Section 2.2. So it says the average size F and square feet. So F is a good choice for that, right? Of new U.S. homes built during year X. Is estimated by the formula this. They give you this formula. Yeah, that's really freaky, actually. Did I get the right? Yeah. Where X is any year from 2002 to 2008. Become an 8. All right, let me stop there for a second. So they gave you the formula. You make sure you understand what the variables represent. Because if you put a number in the wrong place, your equation can't save you, right? So now they ask you, in what year was the average home size 2,504 square feet? So now it just boils down to this. I'm going to say something, and if you don't quite get this problem, I'm not trying to make you feel bad. This is the easy algebra. This is not even real algebra. This is just, I have a function, you plug the number in the right place. This is not like a real word problem, is what I mean to say. It's not a real word problem, because I didn't have to create the function myself. They gave it to me. So where would that 2504 go? For which variable? Yeah, for F. It's not a year. X represents the year built.
So don't complain that there are several variables and you don't know. Just look at how they define the variables and then put the number in the right place. And then the function will work correctly. So if you plug that there, then you want to solve for x. And now it's an equation you can solve for x. Kick ass.
Do you mind doing one or two of the word problems?
Oh, we're going to do several today. Don't worry.
Okay.
Yesterday was an intro.
Okay.
Today we're going to continue. Yes?
Did you number 72 in section
2-2?
Yeah, number 72.
All right, so an athlete, let's see, okay. So everybody got what they want there? Okay. More than you wanted? I understand. So 72, an athlete is 16 miles from home. This one here, right? The athlete problem? 16 miles from home. Running toward home at 6 miles an hour. All right, so write a formula that calculates the distance that the athlete is from home after X hours. So let's draw a picture. All right.
You don't have to be an artist, as I will demonstrate.
Very skinny athlete. They really got to bulk up. I don't know. They're going to probably keel over halfway.
Or he's a runner himself.
Or is it? Yeah, exactly.
And he's being chased by
roadways.
Okay. Yes. So this is 16 miles.
Right. That's. So let me ask you this: how far has he run after 1 hour? How far has he run after 1 hour?
6 miles.
Yeah. So after 1 hour, he ran 6 miles. I'm just saying he's a dude. I can't remember if he said it was a dude or a woman, but I have to pick something. Yeah, okay, athlete. So it could be anything. He ran 6 miles in 1 hour. Is that cool? So, of course, after 2 hours, he would run
12 miles.
12 miles. It's crazy. So what the hell am I doing here? I don't know, Jeff. So do you know how much time he's running for? Do you know how much time he's running? No, we don't. So how much time is he running? X. So I always freak people out when I do that. I just said I didn't know, dude. But in algebra, if you say I don't know, you put an X there, right? Because I'm picking numbers just to see what's going on. So X hours, he ran how far? What do I keep doing? After 1 hour, 6 miles. 2 hours, 12 miles. What do I keep doing? Multiply by 6, because he's going 6 miles an hour, of course, right? So after X hours, how far did he run? 6. X, right? This is 6 times 1. This is 6 times 2. So whatever the number of hours is, I'm going to multiply it by 6. Do you guys see this trick works so often? You give the variable some numbers so your brain has something to latch on. And okay, brain, let's put an X instead of a number, and then there's your little equation. Now this is not quite right yet, because it's all about how far this person is from home. So let's go back. After 1 hour, he ran 6 miles. So how far is he from home?
10 miles.
Distance from home. So after 1 hour, he is 16 miles minus the 6 he ran. He is 10 miles away from home. After 2 hours, how far is he from home?
4 miles. Minus 12.
Yes, 16 minus 12, because he's ran 12 miles now.
4 miles.
You guys still with me here? See, this is much easier than the actual problem, so you should be able to latch on to this. But now I'm going to put in, of course, now after X hours, what do I keep doing? 16 minus this, 16 minus this. So this will be 16 minus 6x. So in general, here's the idea. After X hours, he's going to run 6x miles, because he's running 6 miles an hour. So how far is this distance still from home? 16 minus 6x is what this is. Does that make visual sense? All right, good, maybe. And this is why you guys give up so easily on these kind of problems, because you don't realize you're allowed to do everything I just did,
And sometimes you have to do at least some of what I just did. Now, some of you guys probably can get to the 16 minus 6x quicker than I just did, right? Beautiful. But if you can't, realize you are completely allowed to do this. Just give the variable some numbers so you can see what the hell your brain does to it. Yes, sir?
On the homework, do you want to see all that work?
Not necessarily, and only if you really need to, but I need to see something that tells me where that came from.
So the end state is you want that problem, because I know that myself, and I know that some other people in here can look at that problem and say that he's running for 2 hours and 40 minutes without.
Oh, because what's the rest of the problem? I haven't even looked at the rest of the problem. Determine d when x is 1.5. Find x when oh, you're saying how long until he actually gets home? Okay, and that's not even part of the problem. Yeah, but that's what I thought. I didn't even look at it. I thought they're going to ask how long until he gets home, but they don't. Oh well. And of course, what would you do if they did ask you how long until he gets home? When he's home, how far from home is he?
0.
0. So what would you do? This represents how far from home, so you would set this equal to 0. This is the distance from home. They don't ask that. So this, I can represent with a big ass D. That is the function that represents how far from home this guy is. I know most of you right now are like, oh, God, math, the freaking hell good is this shit. But, I mean, this is the backbone of almost every damn thing that happens nowadays. I have to be able to represent things I don't know. I have to, and then everything is geared. Now I know it, now it's changing, I want to know how is this changing, how is that changing. That's what builds what's going on today. All freaking around you. So now part B. So this is part A. Part B, now you just use the function you just created. So you should be able to do part B and C now. Part B says, determine D when x is 1.5. So they are really nice there. They told you which variable to plug the number in for. And then part C says, find x when D is 5.5. So somebody explain to me physically, when D is 5.5, what does that mean physically?
5.5 miles.
He is
5.5 miles away from home.
beautiful, right? That's the physical interpretation of what that is. I like it. Maybe.
So, with part A, is that the final answer?
Part A, this is the final, because part A just wanted the function. The relationship between how far from home he is and how many hours he's ran. Cool, I like it.
How about 2.2, number 24?
Oh, so this is kind of a precursor to graphing. When you make an XY table, right? This is the one with the table you got to fill in?
Yeah.
Yeah, okay. Let's see. So 2.2, number 24, gives you a function. Actually, just gives you an actual equation. That's why it's a little bit weird. And they say, fill this in. And they give you these values. Is it 0 and 2? And you have to fill these in. So do you see how this is really, we haven't officially done graphing in here yet, but you all should have done XY tables at some point maybe. So if I know the X value, how to get this value, I just take that and plug it in. So if I plug a -1 in here, -2 times -1 is, that should be a 4. Did they put -4? No, good. When I plug a 0 in, what do I get? And so forth. Cool. And then you can see the answer. This is asking you, when is -2x equal to 0? Well, I can see it right there. -2x is 0 when x is 0. So that's kind of a precursor to, if I have a graph, I can actually use the graph to solve equations, because the graph is the plot of all the answers. So when we start graphing things, we'll actually get to that point where we're able to solve equations visually instead of computationally. Whatever you say, Jeff. All right, maybe. So is that cool? So that's really all they want. You just want you to fill in the table, plug the x values in. Cool. All right, anything else from homework? All right. We're going to get back into word problems. Yay. Let's see. I think there were a few more in here I could use. Ooh, yeah. Here we go. Maybe, no. There it is. There we go. All right. Can somebody back there shut that front light off? I think it's the far, yeah, cool, thank you. Like, dude, I know, I've done it. All right, let's do this. I don't think we've done this one yet. Panasonic problem. Oh, we'll do some out of here too. So one big stumbling block for students that have trouble with math is you don't realize that every problem is not different. There are whole categories of problem. They're all the same problem. So you attack each problem like it's its own thing. You're like, we didn't learn this. Yes, we did. It's just got different numbers and the X is in a different place, but it's the same idea. So if you attack word problems with the process I gave you yesterday, most word problems should work if you attack them that way. So we did a problem like number 4 yesterday. So let me remind you about the steps. And then I want you guys to try that problem out. And they have in the book, in the textbook, they actually have basically these same steps written out for you. And on the handout I gave you yesterday, it's got the steps written out for you. So, I can't remember now actually, I gave you the handout and now I forgot. Do I call it step 0? I have some more somewhere. There it is. Oh, I call them A. Okay, that's neat, Jeff. That's a different thing. So step 0, I'm going to add a step, is draw the picture. Actually, I think I made that step. Oh, cool. Draw the picture. I just kind of threw it in the middle of there. If it makes sense. If you're talking about a discount off a car, don't draw a little car. If it's a geometric problem like this one, you probably want to draw the picture and label it so that you don't forget something. And then step A, like I have on the handout, is find the players. So the players involved could be Fred and Bob's salary, like the problem yesterday. Could be the sides of a triangle, the shortest, the third side, and the longest side, right? And you want to use the same words that the problem uses. Step B is then, which one's just X? Make sure I'm agreeing with myself. Yep. Step C is now that you got one of them just X, the other ones build off of that. So on the handout I say transfer from English to Mathish. So that's where if they say it's 2 more than this guy, it's X plus 2. Try to build X. So if one guy's X and the other guy is twice as big, that would be 2X. You're building off of X. That's why the most important step is what the hell is X? And then step D is set up the equation. Solve it. And then step E, make sure you answer the whole question. Right? Complete answer. Oh gosh. So you guys try to do number 4 there. Draw the picture, figure out what's just X, or you can use whatever letter you like. Hell, you can use a little freaking happy face. It's just got to be a symbol that represents an unknown. Do as much as you can on that problem. And real quick, let me do my little rant about this. If you're in driving class, I don't think I've said this yet, have I? If you're in driving class and I say drive to the mall, or I say get to the mall, and you're in driving class, and you walk to the mall, and I'm here, I made it, do I pass? Are you going to pass my driving class if you made it to the mall by walking? So what the hell am I talking about? You're like, what the hell? We don't drive. There's no cars. Are we going to drive? No. If you're in what kind of class? You're in algebra class. So if you get the correct answer, but you didn't use algebra, you're in the same situation as this crazy person that walked to the mall. This is algebra class. So I love that a lot of these problems are easy enough for some of us to just figure out the answers a different way. The point of this class is not to, no, you're not allowed to do that. You must. The point of this class is to have an easy problem so that we can get used to the weird-ass algebra, and the algebra can then tackle the problem no matter how hard it gets. But we want to start at an easy level. So do not get angry at me if I take a lot of points off. If you didn't use algebra, I'm going to take a lot of points off. Because the point of this class is algebra. Okay, go for it. If you had the blue book, this is page 9, if you didn't know. So when you're writing the actual equation, you don't have to put the units in. That's what's probably confusing. It looks like there's more than one word. That should be units, right?
Yeah.
Oh, I see. You thought it was a variable. It's like
No,
the...
it's a.
Yeah, so see, but see, this is also in meters. It's just that W is in meters. Don't put any units in the equation. Put units on the answer. Because otherwise you think it's kind of like a variable. Yeah. 6, yeah. Kick ass, kick ass.
All right, and then another question.
And then you can reduce.
That doesn't.
No, you're mistaken like exponents would become negative, but just flip something for no reason. There I'm flipping because of the division. So the division becomes multiplication. That's what changes, and that's what allows me to flip it. And then you can do or reduce. Yeah. Cool. Thank you. So the length is 5 meters less than twice the width. So which one is going to be just a singular? Which one is the other one dependent? Which one would you have to know first? Yeah, because if I know the width, I can then double it. It's a file way. So the width, called W or X, yeah. So almost always something is going to be a single letter. So if you have this and there's nothing that's just a letter by itself, probably made a mistake. You've got separate things in separate places. So now the length is 5 less than twice that. So what's twice that? And then what's 5 less than that? There you go. So the length is that. So you see how you have parts of it in different places? Cool. Good. All right, I like the width is X. What's the length? So you have 2 players here, the width and the length. So what's it say? Yes, you do. The width is X. So what's twice that? And then what's 5 less than that? So twice that would be 2X, and now 5 less than that. There you go. Yes, exactly. Now label your picture with what you just said. Where's the width for the X? Where's the length for the 2X minus 5? So you have a nice visual of what's going on. Yeah. Keep going. Label them all around. If you set this equally, you're saying the length is in just this one side. But what's supposed to be 8? All the way around. So how do you get all the way around? To add in all the sides, right? Oh, so this is equation, look what it says. What is 2w minus 5? What does it represent? So this equation says the length is 8. But the perimeter is supposed to be 8. So the perimeter would be all the way around. So the 8 is not what's wrong. It's that the other side has to be more than just one side. It has to be all 4 sides. Added together. So now you can find the length and width are, and you can put them on your picture all the way around. And then the equation is the perimeter. I have to do up with all the sides. Add them all up. So your equation is going to come from the relationship between those players. You don't have to set each one equal to something. Yeah, pretty good. So that's 15. And just do me a little favor when you answer the question, make sure, well, this is all right, because you identify, but you're really good at like with. Yeah, that's right. I just put the units on it. Oh, so see this equation? What is 2x minus 1? What does that represent? It only represents the perimeter. And we're not in 3D. I like this number. Yeah, it looks like it's going to be more complicated. Yeah. Nope. They're both negative. Yeah. This is like only $5, only $5, oh, $10. Here's your mix. Squares going on. Those squares here. W plus W is how many W's? 2W. So when you're adding your coefficients, you multiply your exponents. Let's do this one. Alright, so here's the trouble with this. If the length is twice the width minus 5, right? Then that means the width is W. That's why you have a W. So if you have two separate variables, you don't need them. Exactly. Then you can combine, then you don't have two variables. If you have two variables, there's no way you can solve it. I'll do these for units. Alright. Let's do this thing. You got it. Oh, 5 minus 2x. That's the big, yeah, because 5 comes before 2x in the statement, but that's English's problem. When it says 5 less than something, you have to, oh, you really mean this. So that less than, you got to be careful about that. Yeah, and put units. And make sure you identify the width is this and the length is not 25 times 2. That's kind of like checking. The width is 15 meters and the length would be 25. So see, how far did you go around the picture? You went x, 2x minus 5, so you only went halfway. Yeah, there you go. Yeah. All right. Let's see. Let's do this. That was exciting. Okay, just really. If you follow the steps, and the algebra is insanely useful, and I know most of you guys disagree with that statement, but it allows me to do stuff with shit I don't know. I mean, that's insane. It's like, how the hell would I do that? So, of course, our brain balks against that. Your brain goes, I don't know this shit. But you got to go, brain, calm down. If we don't know it, I say, I do know it. It's X. Nah, nah. So, the very first step. So, you can draw a picture. That's a good step. Step 0. I call it step 0 because sometimes you don't do it. All right? What are the players involved? This is step 0. Step A. What are the players involved? The width and the length. Now, is the perimeter a player? No. The perimeter is the game, right? These are the players. Together, they're going to make the perimeter. That perimeter is going to give me the equation eventually, right? Cool. So, did you see the difference between what I mean by players? And then the perimeter is going to be the eventual equation. So, this tells me, once I identify what the players are in English, it tells me I got to give all those things math names to be able to set up an equation. Which one of those, of course, is going to be just a single variable? Yeah, why is the width? Because the length is blah, blah, blah. I got to know the width first, and then I can do that shit to get the length. right? So if I call the width, I'm going to go ahead and call it W. Some of you guys call it X, which is beautiful, right? You can call it freaking L or what? You can, no, maybe not L. It's a bad idea for me. What about the length? So now that the width is W, the length is 5 less than twice the width. So what's twice the width?
2.
And then 5 less than that? All right, cool. So if you put 5 minus 2W, that's why you're getting negative side lengths, which is neat. Right? Your thing exists in another dimension. I don't know what that is. Buckaroo Banzai stuff. So I highly recommend you label the picture with what you've just done, because then it's less likely for you to make mistakes. Everybody that I was walking around looking, everybody that skips everything I just did, most of you had this equation. Because your brain sees 5 less than twice, you go, oh, that's 2x minus 5 or whatever, and then the number's 80. There's an equation, and then you feel good. You made an equation. But what does that equation really say? What is that? What is 2w minus 5? The length. So if I hire you, I got 80 meters of fence, and I'm like, build me a rectangular, and you put 80 meters on one side, I'm like, that's not going to contain my little pet pigs. They're going to run away. Shit, I need the whole thing. So that's no good. That says length is 80. What about the other 3 sides? Shit. So to really get the equation, you got to do all sides. That side plus that side plus that side plus that side. Now that all equals 80. Yes, ma'am.
Can't you just do half of 80 too?
Kick ass. So you could do, and this I showed you this yesterday, but I always want to start with the truly by the book kind of way. But there's all these little shortcuts. You could, if you put W plus 2W minus 5. Some of you guys had this and you put 80, but how far did I go if I did that? I only went halfway. So this would have to equal 40. And these are actually the exact same equation, you just don't realize it. So you can start either place. You can do that one too, you get to the same answer. So if we use this one for a second, I would have how many W's? 6 W's. And do the 5's cancel? Yeah, they're both the same sign, so they add. So I get minus 10 equals 80. And now that's looking really nice. And real quick, just to show you, the next step on this one would be 3W minus 5 equals 40, right? And if I cut everything here in half, don't I get this? They're the exact same equation. They just started a little bit later. Okay, maybe. All right. And then how do I finish this one out? At 10.
19.
And then finally, divide by 6. W equals 15. So now up here you can put 15 what's? Meters. Cool. And then what's the length got to be? It'll be twice. Yeah, eventually be that. Twice 15 minus 5, and that's going to be 25 meters. I like it. And does it do what it's supposed to do? Yes. If you add that up, you get 40, and if you double that, you get 80. That's all the way around. That's 80 meters. Cool. Kick ass. So a class like this is really interesting to teach, because some of you guys are like, I finished that like a minute in, dude. What the hell? Come on. And the rest of you are like, I still don't freaking understand what the hell just happened. So I'm always going to address the people that are having the most trouble. So if this is no problem for you, I'm really sorry. You can do some homework. You can make some corrections in the quiz. You got other stuff to do, right? Stare at your favorite wall. If you haven't picked a favorite wall, you should do so now. Oh, all right. Let's look at number 6 real quick, because distance rate time problems are like the classic evil math problem. The sound sort of sounds like that problem with a dude running home. So bus 160 miles east of North Dakota-Montana border. It's traveling directly west at 70 miles per hour. How long will it take for the bus to be 295 miles west of the border? Do you guys see how, let me say this again. When you read through that, do you see how this is the exact same problem as a dude running home? Do you guys see how this is true? The dude was a certain distance from home. We're a certain distance from that border. I'm going towards it at a certain speed. He was running home at a certain speed. This is what I meant earlier. This is not a different problem. This is the same damn problem with different numbers. That's all. So the more you start to realize there are categories of problems, and the more you realize I got less to memorize than I thought, math becomes a little bit easier. The people that think I got to memorize everything for every problem, holy shit, there's no room in this brain for that. You start to forget your name and shit, and how to breathe. Breathing is important. All right. So where the hell do I start on this problem? What's the first step? Almost always in a word problem. Is there something to draw here? I could. You don't really need to, though. What's the first step always then? Draw the picture and then what? What are the players? Cool. So what is the unknown here? No, I know all that stuff about distance. I know everything about distance. Yeah, I don't know how long it's going to take, right? So the unknown, so I can define, so time in hours is, what letter do you want to use? X, kick-ass. It's a good choice because T for me looks like plus, so let's stick with X. All right, time is X. So tell me, can you kind of do like we did for the problem? After X hours, how far will we have traveled?
70 miles.
After 1 hour, I would have traveled 70 miles. After 2 hours, we would have traveled 140 miles. So after X hours, how far did we travel? 70X, right? Whatever number of hours it is, I'm going to multiply by 70. So after X hours, we've gone, the distance we traveled is 70X. So what I'm doing right now is I'm kind of trying to build to my equation. So what I really want to know is, what's the 295 miles represent? Distance between where we are at some point and the border, right? So that's the equation I want to create. I want to create an equation that represents how far away from the border we still are. So how far away from the border are we if we haven't gone any distance?
160 miles.
We're 160 miles to begin with, right? In this bus. So I'm 160 miles. Is that distance going to decrease or increase as I'm traveling? Decrease. I'm getting closer and closer. So after X hours, we've gone 70X miles. How close would we be to the border now? 160. Maybe drawing a picture is a good idea. So we start off 160 miles away. And then we go 70X miles. How far are we still got to go?
90.
No, they're not like terms. Careful. If we're 160 miles away and then I go 20 miles, how far do I still have to go? So if I'm 160 miles away and I go 20 miles, how far do I still have to go? 140. What do you always do? 160 minus whatever the hell that is, right? So if we've gone 70X miles, 160 minus 70X. The people saying 90, these are not like terms. You can't combine 160 and 70X's, right? They're not like terms. So how far do I still have to go? 160 minus how far I've gone. So in general, that makes sense. If I got a certain distance to go, how far do I have to go if I've gone a little bit? 160 minus how far I've gone so far. And what do we want that to be now? Where's my equation going to come from? I want that distance to be how much? How close do I want to be? Now what did I do? Am I doing this in reverse? I'm evil.
I think it's going away.
Yeah, it's going away from it. That's my bad. I try to make it too much like that other problem. So let me see if I can salvage this. So we're going away from the border, right? That's my bad. That's the only way we can be 295 miles away. So if we're going away from the border, we're getting further away. The nice thing, the way to salvage this, all I have to do, instead of subtracting how far we've gone, I'm going to add how far we've gone. Cool. So that's the total distance. So this is my bad. So we're 160 miles away, and then we're adding more distance on because we're going away from it. Right? I wasn't paying attention to my east and my west.
Equals 290.
Yes, cool. So then I want this total distance, how far I was away to begin with, plus the distance I've traveled. I want that to be 295 miles. And now it's the easy step. Now you just got to solve that equation.
So if you do it like this is 1.
What's happening here?
This is 169. This is equals to 70 miles per hour.
How could 160 miles equal 70 miles per hour? One's a distance and one's a speed. Like they can't equal each other. Yeah. And it's 70 and 160 don't directly relate. It's just that's where we start. So the 70 didn't have anything to do with the 160. We just were there, and then there's a tsunami, and we're like, let's get the hell away from here, right? Okay. Or whatever happened. All right, let's do another one. Those are kind of freaky. Let's see. I think I want to do some out of the book, maybe. Yes, cool. So out of the book here, so you can see ones that will actually be in your homework. Let's take a step back for a second. Of course, my magic book has all the answers, but oh well. Look at number 26. So this is the one I call, this is like one step away from math. So try to set that equation up for number 26. Oh, this is page 121. This is section 2.3. Oh, and solve it.
Oh.
Yeah. So once you got the equation, that should be now should be the easy step, hopefully. Solving equations are the bread and butter. We should be pretty good at that. Yeah, 26. And you already know what your answer should be. I know at least one person told me they have the instructor's edition, which is fine. But be real careful. Some of you guys turned in the homework and your work does not lead to the answer. There's no allowed miracle happening. And I don't know if your past teachers didn't really grade your work and you can get away with that shit. You're not going to get away with it here. Your work better match up with what your answer is. Don't suddenly have the right answer show up out of nowhere. Ain't no good. Work is key. Work is king.
That's right.
So how do I set this up?
The number is X.
Good. So this is a good place. So the number is X. And a problem like this, I don't even have to really follow the steps because, like I said, it's just like somebody reading in English an equation. So I just got to put it back into an equation. So 3 times the number.
3 by X.
3x is equals. What's it say? 18 less than that number. X minus 18. Remember that less than is evil. Right? If I'm 2 less than you and you're 10, I'm 8. I'm not negative 8. You're going to be born in 8 years. What? So 3x is x minus 18, and now that's the easy step now, right? And I can see where the negative 9 comes from. What would I do? Subtract x, get your x's together first. Divide by 2, and thankfully the book is right. human, they have typos sometimes. All right, so that's not too bad. Let all those be that simple. You just got to remember, like, quotient means division. You just got to remember your definitions of your words. So let's do something a little more interesting. Can you see this one? Yes.
30.
Is 31 that I assigned? I think so. Sure, why not? We'll do 30. And you've all heard this kind of problem before. And let me say a real quick thing. I am just as annoyed at the guy. There's a problem in here where the guy forgot how much money he put into accounts. I think I already said this at some point. I'm like, who the hell are you, person? You got so much. I forgot how much money I put in there. I'm like, holy shit, I know exactly how much money, because I don't have much. It's very easy to keep track. So I understand that a lot of the problems we do in here, just to get used to the processes, the problems themselves are kind of like, this wouldn't happen. You got to get over that. It's very difficult to make a true life problem because we just don't know enough math yet. So these problems are going to be a little bit like, who the hell is this person? But it's all about the process. So number 30, these kind of problems happen. This is not like number 26. This is a little bit more removed from math. This is purely in English. 26, I would call that pseudo-math. And this is the kind of problem, if you didn't have algebra, it would not be really easy to get the answer. You could, if you didn't use algebra, you could actually get the answer. So who are the players in this problem? It's pretty simple. Mother and daughter, their ages, right? So mother, age, and daughter's age. So which one is just X? The daughter, good. So I got to know her age first because the mother is 15 older than twice. Oh crap, so I got to know the daughter first. So you should all be able to find which one is just X. So in this case, the daughter, like it. So then what's the mama? 2x plus 15. So it's 15 older.
2x
Increased, yeah, so 2x plus 15. This is, if you wrote 15 plus 2x, you're actually okay, but get used to turning it around in case it's a less than. So you're just kind of used to turning it around. Because addition, of course, goes both ways. If the mother is 49 years old, how old is the daughter? Is that the one we're on?
Yeah.
Okay. So this is interesting. Now, this is interesting. In the perimeter problem, in the triangle problem, we added up all the sides because it was perimeter. What is the idea here, though? Does it say the total age? That wouldn't even make sense. I wouldn't say, our total age is this, so we should be able to, what the hell are you adding the ages up? So what does it say? What's the relationship? The mother is 49.
So this is the conclusion. This is the result.
True, but how would I set my equation? What would my equation say?
2x plus 15 equals 40.
You would only have the mother's equation equal to...
Yeah, you're right over there, I heard you. And you're right too. Good. It wouldn't be x plus 2x plus 15. Don't suddenly think that every word problem you're adding, this is not a perimeter of people's ages. What the hell does that look like? They're laying down.